Your harness will have flaws. They all do. Let's make sure that they're the ones that don't leave you stranded on the side of the road. If you're thinking about or in the process of building a wiring harness for your standalone ECU and you're starting to feel anxious about not knowing what you don't know, this video is for you. Now, the first thing I want to call out is a bit of a disclaimer. A lot of people pursue building a wiring harness as a cost-saving measure, not because options don't exist that could work for their application, but because it seems like it would be cheaper to build your own rather than pay that big scary price tag up front for one that's ready to go. Now that I've done this a couple times, I can pretty confidently say that if you are going to build a quality wiring harness, you are not going to spend less money doing it yourself, especially if it's the first time that you're doing it and you don't yet have the tools or supplies and you haven't gone through the trial and error of making those mistakes and inherently wasting money in the project while you go through that. You can cut cost by using cheaper materials, but that is going to significantly degrade the quality of your harness. It'll probably work fine right away, but you won't find out until you're off driving somewhere and then you get stranded in your car on the side of the road. And to me, that's the worst case scenario. So if you just want to build a wiring harness for a car that's kind of a dyno queen, you just want to put it together, make a couple power runs, have your dyno sheet ready to go and then park it, sure, you can use some cheaper wiring and other components. But if you want a car that you can actually drive a lot and not worry about having issues with your wiring, it is going to be expensive. It's going to be very expensive. For this car here, to build my new wiring harness and rewire the front half of the car, so all the lights and everything, I spent nearly $3,000 building that wiring harness and getting all of those components. It is very expensive. So I know that no one's going to listen to this. You're still going to say, yeah, I can do it cheaper. I don't think you can, but if you want to try it, go for it. If all of that didn't dissuade you, or maybe there just isn't a pre-made harness available for your application, then let's continue. Let me be clear, I am not an engineer, but I do know what it feels like to be in your shoes. When I built my harness, I was lucky enough to have some very experienced friends who were able to help me with answering some questions and just generally quieting the anxiety and worrying that I was feeling about making sure that I was doing everything correctly as I made all of those 1,000 little decisions while building my harness. But I realized not everyone has that. Over the next few minutes, I'll share all of the tips, tricks, and mistakes that I made while building 2 different wiring harnesses for this project. As you're watching, if there's something that you want to share from your experience, go ahead and drop that in the comments. I don't know everything, but I want to share what I do know, and we can make this video a forum for people to learn as much as they can and help them as they get started building their first harness. When you're taking on building a wiring harness at this scale, in a lot of cases, you're going to be working with different components and suppliers that you've never had to before. There are a lot of different suppliers out there, but 3 I want to mention right off the bat that everyone should know and keep these in mind, especially if you don't have others already that are go-tos for you. The first is ProWire USA. They are an excellent supplier of very high quality motorsport grade wiring supplies. For me, that has been a go-to source to find a lot of things. I don't get everything there, but they tend to have just about everything that you would need. And the other thing that's nice is they only carry really high quality components. To me, that is one of the things that was really hard to figure out when I was first building my harness is what are the right things to use? How do I know if something is good or if it's kind of just junk that's not going to hold up very well? Because I had used enough supplies for smaller electrical projects in the past where I could tell over a while that the quality just wasn't great. You use cheap heat shrink and it starts kind of getting crunchy and flaking apart over time, or wiring just doesn't hold up very well, or it's not very flexible. And that can be kind of a frustrating experience trying to figure out where to even get things. So ProWire USA is a great spot anytime that you are thinking of some sort of component that you need related to building a wiring harness for a car. Check them out. They have just about everything. They also have a lot of things that you do not need that would take you into a category of motorsport wiring that is far beyond what is necessary for most people. I'll also say that using some of these components can be really fun to the point that you get a little bit carried away with how far can I go with making this really, really nice. Like there's heat shrink boots and other things that are preformed into having Ys and Ts, and that's really nice, but it's also just not necessary for most projects or people. It's just not something you really need to do. So ProWire USA is fantastic. Waytech or Ytech, I'm not really sure the right way to say it, is another electrical supplier that has lots of different components, all of the different terminals you could ever possibly need. They will have that there. It is a little bit more challenging to search their site and find things, especially if this is not something that you do day to day in your day job, which that's the case for me. This is not at all related to what I do, but they do have a lot of good things available there. And then the third that I'll mention is Del City. That is another supplier that has a lot of great components and wiring and other things available. They've become a go-to for me more recently with building the harness for this car the second time. I've gotten a lot of wiring from them and some other components as well. So those three are great. ProWire USA, Waytech, and Del City, definite go-tos to keep in mind. So definitely take a look at what's out there, but it's good to just have some go-tos there. Another note that I'll add is that it is going to be very tempting to cut corners as you're going through this project. You're going to have times when you run out of supplies and you either need to order more wiring or terminals or something, or you find out that you ordered the wrong ones. And it's going to be very tempting to use something that isn't quite right, but you can make it work. Or instead of ordering more wiring from ProWire or Del City, you say, oh, I'll just run down the street to the hardware store and get some. Do not do that. Resist that temptation. That is one of the hardest things. It's something that I have always struggled with. When you're in a groove and making progress on something and you're almost at a point of a significant milestone of getting something done, but then you just run out of supplies. It's worth putting the project on hold for a week or even a couple weeks if it means getting a good quality component that you can have peace of mind is not going to create a problem, especially when it's buried deep in your engine bay or in the dash or something. I will specifically call out Amazon here. Be really cautious about that. Don't buy wiring components and wiring supplies from Amazon. There are some tools that you can get that might be okay, and I'll actually mention some and link some in the description. But when it comes to wiring supplies themselves, do not get them from Amazon. It is very difficult to tell what you are actually getting many times when you're ordering something to Amazon. And just in general, almost everything wiring related on Amazon is going to be very poor quality. So we talked a little bit about where to get good quality wiring and components, but I want to dig in a little deeper on that into specifics because there are so many different options available and it can be very overwhelming to try to figure out which to use. Wiring, terminals, and other components are not all created equal, even when you're ordering from a reputable supplier like ProWire or Del City or the others. Let's start with wire. Just the wire itself. Seems like something very simple. A wire is a wire, no big deal. Definitely not the case. There's a huge range of wire types available and the cost of them varies widely. The best harnesses use TEFZEL wire, but you really pay for the quality of that. That is a motorsport level wire, and in general, it's just not necessary for what most people are doing. A step down from that would be TXL wire, which is not quite as good, but it's still a really good quality option that is on par with what you get in OEM harnesses. It's also what commonly comes in the kind of medium to higher end tier of standalone ECUs as well. For instance, MaxxECU has a universal harness that is built out of TXL wire. You'll notice when you look at TXL wire that despite being more affordable than TFCL, it is still quite expensive and a lot more expensive than just whatever random wire you can get on Amazon. But that is for good reason. It is actually intended for this application and you can rely on it to work well. If the cost of good wire scares you off, then I would highly recommend rethinking building your own harness. That is just a foundational thing that you have to spend money on. Otherwise, your harness is not going to last. I used mostly TXL wire when I wired this car. The base of the harness was built from a MaxxECU universal harness, and then there was lots of other wiring that I had to add in to supplement that for the engine harness, as well as all of the other wiring for the rest of the car and the battery and everything else. One of the benefits of using TXL wire or TFCL wire is that it is a lot thinner and more flexible than you may be used to if you haven't used a high quality wire like this before. If you take that TXL or TFCL wire and compare that to a standard primary wire that you get from the hardware store, you'll notice that those higher quality wires are much thinner and far more flexible than that typical sort of hardware store primary wire. In your harness, all of the connections and joints are the places that are most likely to fail. So anywhere that you have a joint in the wire, either it's going to a connector or it's splicing into another wire or splitting off from some other wire, those are the spots where harnesses can fail. And this is usually where you have crimps. The go-to method for building automotive wiring harnesses is using crimps. I'm not going to talk about crimping versus soldering at all. It is a done deal. Crimping is the methodology to use. You just need to make sure that you have the right crimpers and you are using them effectively to create high quality crimps, which is harder than it may sound, especially if you haven't done it a lot before. When you're building harnesses for automotive standalone ECUs, there are lots of different connectors that you have to use for all the different components. And inside of those connectors are different terminals, and they all work a little bit differently. And there are different dies or crimpers that you need in order to execute a quality crimp that holds that wire well without being over crimped to the point that the terminal is damaged and may fail. The first tip is simple. We want to minimize the number of opportunities for failure. That means minimizing the number of joints in the harness. That can be splices, it can be terminals for connectors. So as you're building your harness, just keep that in mind. Think about, do I need to have this splicing here? Is there another way to do this that would allow me to have fewer splices and connections in the wire? Because each of those is an opportunity for failure. Probably the most common example of this is when you're wiring up connectors. For example, when you're wiring in your fuel injectors, it's really common to find pigtails that are available that have the connector that are pre-terminated with just a length of 4 inches or so of wire, and then you can just simply splice that pigtail into the harness. That makes it really easy. However, now you have 2 points of failure where you could have 1. When possible, avoid pigtails. Instead, find unterminated connector kits that have your plastic connector housing as well as the terminals and any seals that may be required. Additionally, from a purely vane standpoint, it also makes your harness look a lot better when you don't have a lot of splices all over the place. Splices tend to be one of the bulkier parts of your harness because you can see the thin wire and then it expands where there's a splice and then continues. So anytime you have a splice, it's going to be noticeable. It makes the harness a little bit less flexible. It doesn't look as good, but of course, more importantly, it just is more failure prone. So keep that in mind. Avoid pigtails whenever possible. Secondly, Supporting the crimped connection is also important. For splices or spade connectors, this usually means using some adhesive heat shrink that goes over that terminal and then extends past the terminal just a little bit so that it's holding onto the wire, and then you don't have the wire trying to move at the end of that terminal, weakening that and increasing the potential for that crimp to fail. You have both of them supported, the terminal and the wire, and it's just the wire that's moving. It's not putting any kind of load onto that crimp itself. Raychem SCL is a great heat shrink to use for this. It has adhesive in it and it dries semi-rigid, so it gives really good support to the ends of those wires and terminals. I talked a little bit about crimping and making sure that you have high quality wiring components to ensure that your harness lasts. However, you also need to make sure that you have the right tools for the job to crimp those connections. It is an absolute must to get a decent set of crimpers. You can get some reasonable sets of crimpers with interchangeable dies that will handle just about everything you need. I'll share the crimpers that I use. I have links in the description for those. I have one set that I got on Amazon actually that have decent quality, and they have a lot of different dies that cover most of the terminals that I use. I also have another crimper set from Wirefy that covers some other styles that are not included in the interchangeable die set that I have. And then in addition, I also have a hydraulic battery cable crimper that is intended for much larger gauge wire, such as what you use for the battery or the alternator and other things. That one I don't use as much, but when you need it, you really need it. That's something you can just get at Harbor Freight. They probably have the same on Amazon. Two other tools that I definitely recommend picking up when you're doing any sort of significant wiring project. One is a high quality set of flush cut pliers. I use the Crimping brand. They work really nicely. They're very convenient to use. They make nice, very flush cuts. And then another thing that's really nice to have is a good set of strippers. I use a set of Crimping strippers as well that I can easily operate with one hand, just put it on the wire, and in one motion, it quickly strips that. That's really nice, especially when you are working on this and you are making hundreds of those connections to terminals where you need to quickly strip that. There are a few different specific products that I want to call out for wiring components that I definitely recommend that you use as you're trying to figure out what makes the most sense for your car. I really like Raychem heat shrink, specifically Raychem DR-25. That is kind of just the industry standard go-to for very high quality heat shrink. It is really just ideal for this environment. It stays super flexible. It has great abrasion resistance. It's also fuel resistant. I don't know of anything that holds up better in an engine bay. If you have the budget for it, that is by far the best thing to use. And it also just kind of makes the project fun. Seeing how it turns out is really nice. It's not like any other heat shrink that I've used before. That works really well as just kind of your go-to. So I'll use that as kind of the overall final sheathing for the harness for each of the branches on it. And anytime I want to put some heat shrink on something that is not something that needs to have some adhesive or sealant, I'll use that. I already mentioned Raychem SCL. That is the adhesive lined heat shrink that dries pretty rigid. So it's very different from DR-25, where DR-25 is non-adhesive lined. It's very, very flexible. It is a 2-to-1 shrink ratio, meaning that it shrinks down to half its original size. Then there's Raychem SCL. That is adhesive lined. It, I believe, only comes in a little bit smaller diameters. Really good for sealing splices and terminals and anywhere where you need to give some strain relief to a terminal, but that dries very rigid. So that is something where it's going to give support. It is not something that is going to be flexible. So that you want to be very careful about how much you use, because if you put more than you need on the end of a wire, then you're going to have that whole area being rigid before it's able to bend and loop around. Because Raychem SCL only comes in smaller sizes, anytime I need a larger sized adhesive lined heat shrink, I've used Raychem ATUM. This is kind of a cross between Raychem DR-25 and Raychem SCL. It's adhesive lined, it's not quite as rigid as Raychem SCL, but it definitely is not a flexible heat shrink. There's a tiny little bit of give to it, but in general, you should think of it as being largely rigid. So if there's somewhere that I need to seal that is a little bit bigger, for instance, any of the joints in the harness where it's branching off into different directions, I'll use Raychem ATUM. Also, Raychem ATUM is a 4:1 heat shrink, meaning it shrinks down to 1/4 of its original size, which works really well for some of that end sealing of those joints when you need to just get it over some connectors or just more bulky wiring. Works really nicely. Anytime you're using Raychem ATUM or any other adhesive lined heat shrink where you're going to be placing that directly over wires or other things that you might want to pull apart at some point, you can use a heat resistant tape called Kapton tape to wrap the harness, and that will allow you to easily remove that adhesive lined heat shrink in the future. I use this on any of the joints in the harness when I'm placing adhesive heat shrink directly over wiring and not just over some of the other DR-25 heat shrink. As far as connectors are concerned, a lot of times you're just having to use whatever is already spec'd for that component and you're just finding the right connector. However, sometimes you will end up adding in a connector either for a sub harness that you're creating or something else. It's really your decision. Anytime you're doing that and you have the choice of what connector to use, I personally like using Deutsch DT and DTM connectors. I think it's a really good quality connector without being really expensive. So it's a good compromise in that way. I know also weather pack connectors are very common. I don't like them quite as much. That's just a personal opinion thing, but those are very common and I believe they're even more cost effective than the Deutsch ones are. Of course, zip ties or cable ties are also part of the project. I try to avoid using a lot of them and just use them when I really need to, but sometimes you need them. Either you're bundling things in your harness or something else. A really simple thing that you can do to make that better is don't use the zip ties that come from the hardware store or Amazon or wherever. They make specific motorsport intended zip ties that have metal tangs in them. They are far higher quality, much nicer to use, and will last a lot longer than those crappy zip ties or cable ties that you get from a hardware store or Amazon. So definitely check those out. Actually, I believe those are even required based on the rule book for certain race classes. As you're finalizing the sheathing for your harness, putting on the final heat shrink or whatever other housing or sheathing for the harness you choose, it's also really nice to put labels on the harness. And there's two different ways that you can go about this. There are some places such as ProWire USA that sell label kits where they will have a kit of heat shrinkable labels ready to go that cover most of the things that you would use. And that works really well. It's very simple. It's cost effective because you don't have to buy a label printer. But if that doesn't cover everything that you need, you can get a label printer for not too much money that can print those labels themselves. And it's not just the typical sort of adhesive printed label that you wrap around. They make cartridges that can print on heat shrink itself. So I'll link one of those as well. I really like having that. That's just one of those things that makes the job fun, having your own specific labels and making sure that it's really easy to figure out what everything is. I use this probably even more inside of the car, like labeling the wiring in the dash. Dash wiring is one of the most maddening things for me, so having lots of labeling on there is really nice. So using those heat shrink labels works great. One note though is that the printing and the actual label itself on those labels can rub off, especially in an environment like an engine bay where it's seeing the outside elements to a certain degree and there's fuels and oils and all those other things. You want to use a clear heat shrink over top of that label to help protect and preserve the ink on that label. That's a definite must if you're going to use those labels. There's a bunch of other tips that I've picked up along the way that are all things that I just kind of naturally learned through the course of building these harnesses, and I would love to have known these earlier on because I could have incorporated them to build a better harness. Tip number 1, smaller wire bundles. I learned this with building this most recent harness for this car, that it works out a lot better to have fewer things bundled in with your final kind of routing. So after you get everything wired up, and then you're just routing it where it needs to go, and then you're putting sheathing over it, and you're deciding, do I want to have a bunch of little branches, or do I want to have just a couple bigger branches? I have found that it works better to have many small branches that are much thinner. That keeps the harness more flexible, and for me, it made it easier to get it routed more accurately where it needed to be, and I didn't have as many situations where there was kind of a little bit of, not necessarily stress between some of the branches, but they're pulling a little bit more in their differing directions than they needed to be. When I did it the second time and I had most things in smaller diameter sections of heat shrink, that allowed much more precise routing and the harness to just kind of more naturally fit in the space. So I would definitely recommend using more smaller bundles of wiring rather than fewer thicker bundles as you're finally packaging it all together. This is a simple one, but tip 2, don't put your connectors on until the very end. If you want to, you can terminate them, but don't actually put them in the connectors until the very end. That's going to make it a lot easier to do the final sheathing where you're putting the heat shrink on and kind of layering that, especially because it's best to put that heat shrink on starting with the end of the wire and then working up the branch. You want to have as little bulk in the harness as possible so that you can keep the diameter of heat shrink that you use as small as you can. The problem with using larger heat shrink is that you'll inevitably run into some times where it just can't shrink down as much as you want it to, and it's no longer tight on the harness. And it just doesn't look as good. It works fine, but doesn't look as nice as it could. The second thing about that is that naturally, as you're shrinking down the heat shrink, the more it shrinks, the thicker the wall gets. And maybe that's good as far as having more abrasion resistance because it's a thicker surface to try to rub through, but it makes it less flexible and the harness is just not quite as nice. So if you can use a smaller diameter heat shrink to kind of snake over the harness, that's going to work the best. Tip number 3, when in doubt, look at a factory harness. A lot of times people like to pretend that anything aftermarket is going to be higher quality and an upgrade from something OEM, but that's really not the case, especially when we're talking about wiring harnesses. OEM wiring harnesses can provide lots of lessons about how to build a harness well. So if you're ever unsure about how to route something or how to connect things, take a look at what an OEM manufacturer did and then try to emulate that. Especially if we're talking about a higher end OEM manufacturer like BMW or Volvo or someone. They're usually doing a pretty good job on their harnesses. This came up on this car when I was wiring the injectors in, and a friend gave me this advice suggesting that I take a look at how the factory spliced out all of the wiring for the injectors, especially because you have one power source coming into those injectors and then just individual grounds that ground out each injector to fire them. So you need to take that one 12-volt wire and then splice it to run it to each of the cylinders. In that case, I was able to take a look at the factory harness and see that they take that splice and then they have wires running out of both sides of it. So that told me that, okay, that probably made sense to do that, rather than thinking, okay, I have to take the one wire and then have to immediately splice it into 5 on this side. I realized, oh, that's dumb. I can just have the wires on each side of it. Another thing I'll add onto that is that a good tip for using splices is to keep the volume of wire the same on either side of that butt splice. There are calculators that you can use online that will convert wire gauge into a volume, and then you can just add that up to see, okay, well, if I want to have the same volume of wire on either side of this butt splice, how many wires do I put in each side if I have a 12 gauge over here and then these are all 18 gauge or something like that. You can use that calculator to help determine that out, have the volume match as closely as possible on either side of a butt splice. Tip number 4, if you're using a bulkhead connector like I did, which I will say is totally unnecessary and definitely something that is mostly vanity, but also it's kind of nice when you have to pull the engine out quickly. If you're doing that, use service loops. What service loops are is just a simple loop in the wire between the harness and where it goes into the connector. And this gives a little bit of extra wire to work with if you need to, and it also gives some natural sort of strain relief off of that terminal that's going into the connector. On the first time that I went to drive this car after building its newest wiring harness, I had an issue where I didn't have spark in one of the cylinders. I ended up having to remove one of the heat shrink boots from that bulkhead connector and then mess around with those wiring in those terminals. And I found that one of those terminals was not fully seated. It was a lot harder than it needed to be to get into those terminals. And if I had used service loops, there would have been a little bit more wire to work with. Thankfully, I didn't need extra length, so I didn't need the service loop for that. However, it still would have been nice. So if you are using bulkhead connectors, I would definitely recommend adding those little service loops, which is just as simple as looping that wire around before it goes in. You're just giving yourself a little bit more wire to work with. Tip number 5, keep your grounds free of any coating. I had an issue with this car that plagued me for months after I took it into a shop for dyno tuning, where the car would just stop running. It would not start at all. The shop saw it start happening, and then it got worse and worse to the point that the car wouldn't run because the grounding was not sufficient, and that was creating noise between the starter and all of the components in the ECU. I ended up having to remove the transmission, thoroughly clean the bell housing flange, and run a tap through all of the bolt holes for the bell housing bolts to get that to work. And as soon as I did that, it ran totally fine. It removed all of that interference. Same thing can go for any of your other grounding points. It's something that's really easy to forget, especially if you're using something like clear coat. Just make sure to mask off any of your grounding points before you paint or coat things, and avoid Loctite in those because that can get in the way to a certain degree as well. That is what happened with my engine. So keep your grounds free of any coating. Make sure to mask those off and even scuff those up. Make sure that you have a really good contact point there. Those grounds are critical. Tip number 6, do not use AI to try to find your wiring pinouts. It will give you something and it will likely be wrong. AI is a great tool to use. It can help you in a lot of ways. And I was actually impressed at some of the ways that it helped me in getting me started toward finding some information when I was doing this harness. However, it is a confident idiot. It does not know if it's right or wrong. It always thinks it's right, and it will tell you things with supreme confidence. So if for some reason you do decide to use it to try to find this information, make sure you have it give you the source and you can manually verify that after you find it. That is super important. Getting those pinouts wrong can be really maddening as something to chase down, and depending on how wrong you are, that might require you to tear apart your harness. Trust me, I tried this. It provided me inaccurate information that was for a completely different component, and it would have been very easy to just use that, and then I would have had this all wrong and would have caused me way more headaches while building this. So if you're doing that, just make sure you have it give you the source, and then you need to manually verify that information so that you are right. Something that I've learned as I take on new projects where it's just something new that I don't have a lot of experience in and I'm not yet comfortable with is having the quick and easy answer where someone just tells you the answer and you don't really understand it, but you just go ahead and use it anyway. That rarely pays off. Because then you have something that you're solely responsible for and you don't really know how it works. So you've got to take the time to dig in and understand things to the point that you have confidence in how everything fits together and works. That's the only way it's going to work out. So I would equate that to being very similar to just having AI give you the answer for the pinout. Make sure that you're able to look up that information and verify it. It can get you started, but that's really it. Conversely though, AI can be really useful for some things that are less specific. For MaxxECU, for instance, there is a ChatGPT expert that is specifically set up for MaxxECU, and that can be really helpful in getting started trying to find some information. Now, it's a very similar thing where you still need to verify that information because it can be wrong. However, if you're just trying to figure out how do I get started doing X thing, and you just have no idea, starting with that can get you moving in a direction. But again, just make sure that you're always verifying that after the fact. You're not just taking ChatGPT's answer at face value and operating based off of that. Now, there's some other things that really don't matter. At least for the majority of projects, they're completely optional and are things that we get fixated upon because we see them on Instagram or other really fancy YouTube channels and things, and it's just stuff that we don't really need to do. It seems cool to do it, but it's not going to actually help you. The first thing is concentric twisting. It's super satisfying to look at. It makes a really clean and neat harness and keeps the wires really kind of compact, but concentric twisting is totally unnecessary for almost any road car street project you're doing. That is a complete motorsport sort of application thing. You do not need to do that. It is not going to make things better for you. If you want to, you can go ahead and do it, but you should not feel like it is something that you have to do. For most people, if they're doing that, they're just doing that to look cool and get some likes. That's it. The second thing is 100% sealed harnesses. Now, this may seem weird, but let me explain. All of the conductive surfaces, so the inside of the wiring, the terminals and the connectors, those all do need to be sealed. You need to keep moisture and water off of those surfaces, otherwise they will corrode. However, the bundles of wiring don't necessarily have to be sealed. So that outer layer of heat shrink that you can optionally put on, and all of the joints between that and the different trees and branches of the harness, those are not absolutely critical to seal. If you look at OEM harnesses, they are almost never sealed in that way. That is another thing that is definitely a motorsport application and is just something that you do not need to do for your project. Just because you see it in an Instagram reel or something, it does not mean it is necessary for you. And it is also something that is very expensive. All of those specific heat shrink boots and things, those are the things that get really expensive really fast and can turn an expensive harness into a really expensive harness. Really, if you want to, you can use something other than heat shrink for that outer protective layer on those branches of the harness. I just use Raychem DR-25 because I think it's a fantastic product. I really like working with it. And I want to have some more protection, but it's not to the level of having it completely 100% sealed, and that's okay. Anyway, those are all the things that I could think about in reflecting about what I wish that I had known before I built my first two harnesses for this car. Hopefully you find this helpful and it gets you a little bit further on your goal to building your harness. And again, if you have something else to add, drop that in the comments, or if there's something else that you have a question on, you can ask that in the comments as well. If I know the answer, I'll add it in there. Otherwise, someone else watching may, and they can help you with your project too. I've had a couple people ask me for the Google Doc that I use to plan out the wiring harness for this car, so I'll include a link to that in the description. Feel free to use that as you want. That is specific to putting a T5 engine into this car using MaxxECU. However, it does demonstrate the approach that I use to plan that out, which is something that I really struggled with when I was first trying to figure this out for this car. What I ended up doing was starting by thinking about what all the components were that I needed to control, and then figured out what each of those components needed to work. Either power, ground, signal, all of those things. And then from there, I traced that back to the ECU, figuring out how I would supply that. You can do this any way you want to, but for me, that's what worked out best. And there's also a couple other pages in there that you can see where I planned out some other things like how I was going to distribute power and ground throughout the harness, because that's another thing where you have to do a lot of splicing and branching and need to make sure that you have everything where it needs to go. So check that out. Let me know if that's helpful or not, or if there's anything else that would be helpful to you as you're trying to complete your project. I've really appreciated all of the help that I've had over the years working on my projects, and I would love to do anything that I can to help you with yours if there's something that I might know. Good luck. You got this.